Okay, this is the 2D calculator first tab implementation video. So this is what the project looks like when you first get it, and as shown in the 2D calculator kind of walkthrough video, Jamie showed you how to do this basic how you would set up this basic vector equation data. So we're pulling this out of renderui.h, which you can get to by right-clicking Open Document there. Let me zoom this up a little. Okay, so right after declaration of renderui, I'm going to want to call it with this member function right here. Renderui set basic. I'll just let that fill in there, and we want to give it a callback. Jamie also showed you what type that callback would be. That is in renderui at the top. You can get there through these type defs. And it's this very first one here. So I'm going to cut and paste that, copy and paste it into my entry point. I'm going to declare it above main and take off type def and this pointer notation, because it's just going to be a function, and name this variable, this parameter data, and we'll just leave this function empty for now. But we need, and we're going to call this my, just like Jamie did. We need to pass this in to set basic vector equation data. That's what it wants first, is a pointer to a function of type basic vector equation callback. Now it also wants 3 floats. We don't have the 3 float pointers, const float pointers. We don't have the float pointers here, but I'm going to pass in vectors, and we'll learn how to convert them to float pointers in a sec. So I'm going to call the results that we're giving back to this basic v1 and basic v2 and basic result, just like we did in class. Okay, that's going to be my first tab right there. That's going to set up the first tab for the render UI, and that's what brings up the GUI with all the vectors on it. Okay, so now in this callback here, we need to take the information from this struct here, data, and create some vectors out of it, and then do some computations with it and return the results. So we're going to pretend we have a vector2 class, and we're going to call it, actually we're going to assign it to basic v1 equals vector2 data.x1 data.y1. Well, we don't have anything defined for vector2 yet, so let's declare some up here. Vector2 basic v1, and oh, look, I misspelled it again. Vector2 basic v2 and vector2 basic result. Okay, now we need to go declare a vector type. And the best place to put that is in our engine project. We have an engine project and the 2D calculator project. This engine project is shared between 2D calculator and the game solution. So go to these header files and do add new item, and we'll create a header that declares this class called vector2, and it opens it up for us. The first thing we'll do is do the header guards. If ndef some unique name that represents this header file. If it's not defined, we want to define it. And then at the other end, endif. And I always like to comment. Endif doesn't take a parameter, so I just like to comment in what we're ending so you can match it up later. Okay. Also, this is in the engine project, so I want to include it in the namespace engine. And inside here is where I want to put my class vector2. Okay. Well, remember to put that semicolon after the end of the class definition. Alright, so in here we're going to have an explicit private section where we have 2 float members x and y. And we're going to need some constructors. We'll put a default one in here that initializes them to 0. That's what the lab says we want. And a second constructor that we can use to, oh look, we didn't name that right, it's vector2. Vector2, and one that takes two float parameters, new x, float new y. This one we're going to assign those new ones to the member variables. So if x1, I'm sorry, x equals new x and y equals new y. So now we can fill in some values for these vectors when we declare them, when we declare them on the stack, etc. So let's go back to entry point. We've included engine.h. Now we want to include vector2.h. And since we made vector2 a member of the namespace, then we want to do a using statement to avoid having to type engine every time we use that. Okay, but we do want to keep it in the engine namespace. Vector2 might be something that's easily called vector2 in another library or another header that you include from somewhere else. So it's very important to include it in our own namespace, in a unique namespace. All right, so down here, basic vector1, basic v1 gets vector2. Let's just start with that for now and see if that works. So I'm going to try to compile that. See what errors I've got. So it says I cannot access private members. I didn't know. I know what I did. I didn't put these vector class defaults to private scope, so I need to put these in a public scope of the class. So now I should be able to declare these. Okay, so we still failed, and the error says it doesn't know what these are. We need to turn them into const float stars, const float pointers. So what we can do in here, and Jamie has a video on this, on the operator overloader. One of the operators we can overload is a type conversion operator. So we're going to turn this into a const float star just by returning the address of x. That's assuming that x and y are right next to each other in memory, and we want the address to the first one so that the data that wants to look at these floats can see them as the first float in the array and the second float in the array. All right. That should work for us. Let's go back and see if it compiles now. It compiled. So now we'll run it, and you can see there's the whole interface right there. So this scalar doesn't work yet. This is the first scalar one. This one works. Modifies our x value of our first vector. That modifies the y value of our first vector. Add or subtract doesn't do much, doesn't do anything. We're not paying attention to it, nor scalar 2, and nothing changes when we move these. And that's right, because we only computed the result for basic v1. Okay, so let's go ahead and compute basic v2. Now that we've got all the stuff we need for it. So it's going to be x2, y2. So we'll run that. And now we've got both vectors we can modify. Okay, it's not computing the sum yet, so let's go back and do that. So basic result equals basic v1 plus basic v2. Okay, we don't have an operator defined yet, so the compiler complains about that. We got to go back to vector2. Now, if we define these operators if we define them in the class definition, declaration, then they will automatically be inline, and we don't need to guard them or declare them outside the class. So let's go ahead and do an operator that returns a vector2. Vector2 operator plus. It receives a vector2, and I'm going to pass in a reference param so that we're not making copies of this vector. I'm going to call it b, and I'm also going to tell everyone who uses this class that this function does not modify the variables inside the class, the members x and y. And that's what this const at the end does. This is going to help maintain immutability, meaning we're not going to change the values of x and y. We're always going to return a new vector whenever we do some operation on it. So we'll return vector 2. We'll use the constructor that we have up above, x plus b dot x and y plus b dot y. Now let's compile that. That looks like it worked. Now we have the red result vector. Looks like it's working correctly. So the tip to tail addition works for the vector. Okay, now these scalar thingies still aren't working, scalar sliders. So let's make those work. Let's go use one. So what we want to do is times the data that's coming in, the data x1 and x and y1 by scalar 1. So let's do that. Data scalar 1 times vector 2 and data scalar 2 times vector 2 of the second vector, the data x2, y2. That should allow us to do the proper scalar, and then they'll be assigned to the resulting basic 1 and basic v, so that when we add them together, they'll be added together of the scalar. Well, that operator doesn't exist yet, so we've got to go back to vector 2, add an operator times with a float scalar. And again, we're guaranteeing that this is not modifying the members of this class. We're going to return a new vector 2, s times x, s times y. However, this is only going to define an operator that uses the scalar on the right, because whenever we do a member operator, binary operator, it always takes a vector 2 on the left and a float on the right. So what we have written here is the other way around, is the float times a vector 2. So in order to get that to work, we have to write a function outside the class that returns a vector 2 operator times, and we can specify the order outside here. We want a float scalar and a const vector 2 reference. We'll call it a. And then we can return a new vector 2 s times a dot x, s times a dot y. And the problem is the compiler's not going to like this, because we are retrieving values from inside the class, and we can't do that unless we're a member function or if we're a friend. So we'll declare ourselves as friend, vector 2 operator multiply float s const vector 2 reference. And we can't make this const. That only works for member functions. Okay, so now we've got this friend function. It's declared outside the class, and it allows us to do this order with a scalar, with a float times a vector. So let's see if that compiles. It compiled. We got lucky. Now we'll see if the scalar stuff works. So we'll make these vectors unique, so you can tell that they are working. Now let's scale the first one. That makes it longer and shorter and negative. So that's working. We'll check the other one. Perfect. So that's doing what we want. Alright, that's as far as I'm going to go. If we have trouble doing the subtract operator, I'll do another video then, if we need it. Thanks a lot, and have fun.